Okay, hello everyone. Think everything is working correctly now. And we are now live. Let me know in the chat if you can see this. But regardless, today we're going to be learning about GraphQL. This is something that I've been putting on the back burner for a while. Been meaning to get a little more tuned with it, and figured this was a good opportunity. So I found this neat tutorial. It's howtographql.com. Just started looking at the first few sections earlier today, and I figured it was a good opportunity to make a video. And so I'm going to be taking some notes on the right here, and if anyone wants to take a look at these later, I put them in the description section of the video. I made it, I believe, public. Yeah, so anyone can view this link. So that is what we are going to be doing. Just to let you know, this is someone coming to GraphQL with very little knowledge. I know kind of the very basics of it. It's alternative to REST. Just mutations and queries and document models and all that kind of stuff, but not very experienced at all. So hopefully if you're watching this and you're in the same shoes, you'll feel better after this, and we'll learn this together. So that is what we are doing. Let's just get right to it. So the neat thing about this place is that it has a bunch of like videos integrated with it too. So if you get bored of the documentation here, you can just watch the video. I may mix them in here and there. We'll probably just watch the video for the first section and then read the later sections. I'm just kind of checking this out before I click on this. Yeah, let's just give this a little watch and I'll give you guys some commentary. All right, so let's learn. Let me know if the volume isn't very good, by the way.
Welcome to the first chapter of How to GraphQL. We're going to start with a basic introduction to give some perspective on this new technology.
I like his accent.
So what is GraphQL? GraphQL is a new API standard that provides a more efficient, powerful, and flexible alternative to REST. It was developed and open sourced by Facebook and is now maintained by a large community of companies and individuals from all over the world.
I didn't know it was made by Facebook.
At its core, GraphQL enables declarative data fetching, where a client can specify exactly what data it needs from an API. Instead of multiple endpoints that return fixed data structures, a GraphQL server only exposes a single endpoint and responds with precisely the data that a client asked for.
Okay, I'm not going to take notes on this section because I think he's just introducing some of the concepts. It's probably going to be more on this later, so let's see.
So how does it all work? Most applications today have the need to fetch data that's stored remotely in some database that's accessible over the internet. That's what servers are used for. Whenever a client needs some information that it wants to display to the user, it sends a request to the server. The server is programmed in a way that it can respond to the request by retrieving the appropriate information from the database and then sends it back to the client.
Much better.
Before we dive deeper into the technical details in the next chapter, let's understand a bit of the historic context in which the concept of REST was developed. REST has been a popular way to expose data from a server. When the concept of REST APIs was developed, client applications were relatively simple and the development speed wasn't nearly where it is today. REST thus was a good fit for many applications. However, the API landscape has radically changed over the last couple of years. In particular, there are three factors that have been challenging the way how APIs are designed. Increased mobile usage, low-powered devices, and sloppy networks were the initial reasons why Facebook developed GraphQL. GraphQL minimizes the amount of data that needs to be transferred over the network and thus majorly improves applications operating under these conditions. The heterogeneous landscape of front-end frameworks and platforms that run client applications make it difficult to build and maintain one API that would fit the requirements of all the different clients. With GraphQL, each client can access precisely the data it needs.
I like that feature a lot. That, like, in the little that I know about it, that you can kind of selectively pick what data out of the model that you want. And that kind of feeds into the fact that, less data usage, less data being transferred over the wire. So I suppose it's better for, mobile phones, mobile apps, and all that. Yeah.
Continuous deployment has become a standard for many companies. Rapid iterations and frequent product updates are indispensable. With REST APIs, the way how data is exposed by the server often needs to be modified to account for specific requirements and design changes on the client side. This hinders fast development practices and product iterations. Now that we've got a bit more perspective on the concept of REST, let's go and understand a bit more about the history of GraphQL and how it came to be. Facebook started using GraphQL already in 2012 in their native mobile apps. Interestingly though, GraphQL mostly has been picked up to be used in the context of web technologies and has gained only little traction in the native mobile space. The first time Facebook publicly spoke about GraphQL was at React.js Conf 2015.
Okay. I don't really care about the history. I don't know if
because
you guys
Facebook
do.
takes off React
I'm
with
just gonna fast
React to
forward
note
here.
that other companies like Netflix or Coursera were working on comparable ideas to make API interactions such as GitHub, Twitter, Yelp, or Shopify, to name only a few.
Okay, lots of people are using it. Got
Such
it.
as GraphQL
Lots of
Radio Pod
summits.
ready for the first chapter of How to
Right.
GraphQL.
Oh, bold claim. Bold claim. And yeah, this is all just introductory stuff. We're not really getting into the meat of it yet. So let's move on. There we go. GraphQL is better than REST. So let's read the documentation on this one. GraphQL is not better than REST. It says sign fine habit revolution, maybe? It's an interesting name. Yeah, let's see. Okay. So over the past decade, REST has become the standard, yet a fuzzy one for designing web APIs, stateless servers, and structured access to resources. However, REST APIs have shown to be too inflexible to keep up with the rapidly changing requirements of the clients that access them. GraphQL was developed to cope with the need for more flexibility and efficiency. This is something that I think most people feel. It solves many of the shortcomings and inefficiencies that developers experience when interacting with REST APIs. Like what? Fetching data from an API. Let's consider a simple example scenario. In a blogging application, an app needs to display the titles of the posts of a specific user. The same screen also displays the names of the last 3 followers. How would that situation be solved with a REST and GraphQL? With REST and GraphQL. Wait, be solved with REST. Aren't they different? Isn't that what they just kind of claimed? Okay, so this is a RESTful example, right? Okay. With REST, you would typically gather the data by accessing multiple endpoints. In the example, these could be user/ID. Okay. To get all the posts. See, what I don't like is that people tend to criticize REST and cherry pick examples. Like, this is a bad example if they're trying to show a screen that has like all this information. Like, why wouldn't you just create an API that returned all this stuff back and then problem solved, right? So I think maybe the reference point that they're giving is a little bit too tied to the very classic definition of REST APIs that look like this, instead of more remote procedure calls type REST APIs. So like, if this is the selling feature, I don't know what to say. I would probably just do like a get homepage API, right? And then that API retrieves all the stuff. Because their argument here is saying, okay, first API call gets ID. Second one gets the post. It uses the ID from the first one, right? Third one gets the followers. That's 3 API calls. Sure, that sucks. And that's a stupid way of doing this. If you were competent, you would do 1 API call that gets all of this and problem solved. Exactly, you're 100% right. See, okay, I'm not crazy. So let's keep on going. Okay, here we go. Here's the selling point. In GraphQL, on the other hand, you simply send a single query to the GraphQL server that includes the concrete data requirements. The server then responds to the JSON object where these requirements are fulfilled. Okay, so, all right, that's kind of neat. So there's a query and they're specifying the ID, it looks like, and I believe this syntax is like the stuff that you want. So like they want the name of the user, they want the posts, and they want the title from every post, and then I don't know what that is. It looks like some kind of filter. And then you retrieve all this data. Oh, okay, so it's still using HTTP. I thought they were using something different. But this is interesting. So I agree, like this is definitely a bonus where you can selectively pick what you're returning back. And I can understand why they may say this is more flexible, because if you want to add data or remove data or reuse an API for another purpose, it may have more data than the caller actually needs. And then that kind of feeds into the whole point of reducing the size of your calls, right? Where if you're calling an API and you're not using all the data that it's giving you, then arguably you should be calling a different API or doing something slightly differently. So I can see the advantage there. Okay, that makes sense. So this is what the response looks like. So there's a concept of queries. Sorry, I forgot I was taking notes, so maybe I should go back here. So far it's just like observations. Okay. I mean, I suppose I can include some stuff here. So like some of the advantages. Hey, Arby. Less over/underfetching, more flexibility. Classic APIs are more rigid and may provide redundant data, something like that. I forget what the other advantage was. Anyways, let's keep on going. One of the most common problems with REST is that of over and underfetching. This happens because the only way for a client to download data is by hitting endpoints that return fixed data. That's true. It's very difficult to design the API in a way that's able to provide clients with the exact data needs. That's not true. I've built APIs where I take in arguments that tell me how much like detail they want in the response. So isn't that effectively the same thing? And like, I know I'm coming at this pretty skeptical because I hate when people say like something is the rage when really it's like just like what lipstick with a pig on it kind of can look like sometimes. But there's ways to do this that, they're not first class citizens and first class use cases, but you can emulate the same kind of behavior. Thinking graphs, not endpoints. That's cute. Overfetching means that a client downloads more information than is actually required in the app. Imagine, for example, a screen that needs to display. Okay. I think everyone knows probably what overfetching is. It's that, if you're calling and you're getting a bunch of data, maybe you don't want all that data, but you're getting all that data anyways. So it takes capacity to retrieve that, download the raw JSON back, and then, do something with that information. Underfetching and the n+1 problem. Another issue is underfetching with the n+1 requests. Right, when something doesn't provide enough of the required information. So this is what they were talking about here, where in this example, if you wanted to show a homepage that consists of these three things, you need to make this call, you get some information back. You make this call, you get the information back, so on and so forth. My claim is that you can solve this with one API that does all of this stuff, but I suppose the opposite argument to that would be that anytime this homepage changes now, you need to modify that API. Guess that could be true, but kind of playing devil's advocate here. More advantages. Okay, I already got overfetching, underfetching. Okay. Common pattern with REST APIs is to structure the endpoints according to the views that you have inside your app. This is handy since it allows the client to get all the required information for the particular view. That is true. The major drawback of this approach is that it doesn't allow for rapid iterations on the front end. With every change that is made to the UI, there is a high risk that now there is more or less data required than before. Consequently, the backend needs to be adjusted as well to account for the new data needs. This kills productivity and notably slows down the ability to incorporate user feedback. That's a fair point. With GraphQL, the problem is solved thanks to the flexible nature of GraphQL. Changes on the client side can be made without any extra work on the server. Since clients can specify their exact data requirements, no backend engineer needs to make adjustments when the design and data needs on the front end to change. This is interesting. Doesn't this put too much power in the side of the front end or the client? Like, what if I'm just like conceptualizing this correctly, doesn't this mean that, you know, you're exposing a model of something? Maybe it's like a customer, maybe it's a transaction, and then whoever wants can basically poke at it and get the data back. But what if you want to like staple on business logic and you don't want to store something, you know? Like, does this mean that, like, how does that work? How do you like intercept requests and do stuff kind of thing? That's what I'm wondering. But this is kind of neat, but starting to make me feel that you're giving a lot of power to the client, which isn't always a good thing. GraphQL, so insightful analytics allows you to have fine-grained insights about the data that's requested on the back end. They specify exactly what information it's interested in. It's possible to gain a deep understanding of how the available data is being used. This can, for example, help in evolving an API and deprecating specific fields. Interesting. That's kind of cool. You can hash the query and check in the back end. There are libs that help with that. That's good to know. Thank you for that. With GraphQL, you can also do low-level performance monitoring of the requests that are processed by your server. GraphQL uses the concept of resolver functions. So do I need to like, I feel like there's going to be more on this, but provides crucial insights. Okay. Benefits of a schema and type system. GraphQL uses strong type systems to define the capabilities. All the types that are exposed in an API are written down in a schema using the GraphQL schema definition language. Schema helps serve as the contract between the client and the server. Okay, so this is like where you define the structure, I guess, of the API. So that's cool. I guess it still operates within the constraints. Business logic goes in the resolvers. Okay, that's good to know. I guess like you implement the resolvers then? Or I don't know. I've seen products like AWS AppSync where you just kind of click and go and it handles all this stuff, but I don't know how flexible it is to add custom logic there. I would hope it is. Playground and self-documenting nature of GraphQL is a slight plus. That seems correct because you're straight up defining your documentation as part of your APIs, right? I mean, in order to create your APIs, you must create documentation. It makes sense. Front-end teams can easily test their applications by mocking the required data structures. Once the server is ready, the switch can be flipped for the client apps to load the data from the actual API. But then REST APIs have that too. Swagger, exactly, right? There's whatever they're saying here where there's like documentation, there's a counterpart for just classic-based REST APIs. So, quiz time. What is a benefit of the GraphQL schema and strong type system? Not that. Once the schema is defined, front-end and back-end teams can work independently from one another. Probably right. Solves GraphQL. This one? Yay. Okay, go to next chapter. I think I want to watch the video on this one. Okay, core concepts. This seems where I need to actually take notes. Let's watch the video.
Welcome to the third chapter of How to GraphQL. In this chapter, you're going to learn about some fundamental language constructs of GraphQL, such as the GraphQL schema, queries, mutations, and subscriptions. In the second part of this video, I will demonstrate how you can experiment with your own GraphQL sandbox environment to apply what you learned in practice. GraphQL has its own type system that's used to define the schema of an API. The syntax for writing schemas is called the schema definition language.
All right, stop. Schema Definition language defines what? Contract or no, types of APIs.
Or short, SDL. Here's an example how we can use the SDL to define two simple types. One is called person, and the other type is called post. The person type has two fields. They're called name and age, and are of the types string and int. The exclamation point following the type means that this field is required. Post only has one field that's called title and is of type string. It's also possible to express relationships between types. In GraphQL, that's simply called a relation. Let's add a relation between the person and the post types to express that one person can be the author of many posts. We first add the author field to the post type. Now, every post that is created needs to be associated with a person who is the author of it. Next, we add the posts field to the person type to express that a person...
Wait, what did he do here? So person, okay. And then he added person to post, and this means required. Okay, author, yeah. Oh, I see what he did. Okay, so this is pointing to this, and this is an array. Required and required. Got it.
Can write multiple posts. The syntax to specify that something is a list in the SDL is similar to many programming languages. It uses square brackets. Notice that we just defined a one-to-many relationship between the person and the post types. Let's now discuss how you can fetch data from an API by writing GraphQL queries.
Okay, hold on. I want to take a screenshot of that to include in my notes. Oh, you guys can't see this screen, I don't think. Can you? Maybe. Sign fine. By the way, be a better dev. Your channel's a gold mine. Thanks for the great content. Thanks, man. I appreciate that. It's always nice to hear kind words. I've been trying to keep up with the winter break now and making lots of videos, so expect more. What was I saying? Okay, so these are type definitions. Type definitions means required. What else do we learn? You can embed types into other types to create relationships, i.e., you guys can still see this, right? Yes. Person to posts. All right, I think that makes sense.
Queries. When working with REST APIs, data is loaded from specific endpoints. Each endpoint has a clearly defined structure of the information that it returns. This means that with REST, the data requirements of a client are effectively encoded in the URL that it connects to. The approach that's taken in GraphQL is radically different. Instead of having multiple endpoints that return fixed data structures, GraphQL APIs typically only expose a single endpoint. This works because the structure of the data that's returned is not fixed. Instead, it's completely flexible and lets the client decide what data is actually needed. That also means that the client needs to send more information to the server to express its data needs. This information is called a query. Let's now take a look at an example query that a client could send over to a server.
Okay, so queries are what you would expect, obviously. Queries are the requests clients make to the server. The client defines the components of the data model that it would like. Right? Sorry, I just need to take off my jacket. It's getting hot in here. Let's keep watching.
The all persons field that you can see in this query is called the root field of the query. Everything that follows the root field is called the payload of the query. This particular query would return a list of all the persons that are currently stored in the database. Here is an example response. Notice that each person only has the name in the response, but the age is not returned by the server. That's because the name was the only field that was specified in the query's payload.
Is this the name? Like, what is this? All persons. Is that the name of the query? Who defines that? I don't really know yet, but let's take a screenshot. Query example. Yes. Okay, perfect. So this is the name of the query then, all persons. I have a question. Are there like hands-on tutorials with various AWS services that walks you through building various types of apps/services? Do you mean like by AWS? Because there's guides. I don't think there's videos. There are very few videos on that, which is kind of what I was trying to do with my channel, is like show people what they need to care about and how to do things. I'm thinking about doing more videos where I build actual applications and kind of show you the entire process. For example, like building a completely serverless backend with a couple like DynamoDB tables in the backend, you know, and have like full CD and full CI set up, like stuff like that. I've been thinking about doing that. I'm not sure if there's enough appeal for that kind of stuff. So maybe if you guys want to tell me, that would be great. Or if you just like the kind of the videos I'm doing now, where I just kind of do overviews and all that kind of stuff. That would be great. Cool. Okay, so maybe I'll try one out and see how it goes. Anyways, let's keep on going with this topic here.
If the client also needed the person's age, all it has to do is slightly adjust the query and include the new field in the query's payload. Now, the server will also include the age of each person in its response. In a GraphQL query, each field can have 0 or more arguments if that is specified in the GraphQL schema. For example, the all persons field could have a last parameter to only return up to a specific number of persons.
Oh, that's what
Here's what a corresponding query would look like. Now the server only returns the last 2 persons that have been stored in the database. One of the major strengths of GraphQL is that it allows for naturally querying nested information. For example, if you wanted to load all the posts that each person has written as additional information, you could simply follow the structure of your types to request this information. So this is what the corresponding query would look like.
How does, like, who manages the database here? Like, I mean, you have a person to post like relationship, right? So is all this managed for you? Or do you still have to build the services for this that actually host this data? Like, I'm struggling to see how this works. Maybe the answer will become more apparent. Let's just keep going.
The server will now resolve this query and include the list of posts that are associated with each person that is being returned. So now we also see that each person has a list of posts in the server response. Next to requesting information from a server, the majority of applications also need some way of making changes to the data that's currently stored in the backend. With GraphQL, these changes are made using so-called mutations. There generally are 3 kinds of mutations. Mutations for creating new data, updating existing data, and deleting existing data. Mutations generally follow the same syntactical structure as queries, but they always need to start with the mutation keyword. Now let's take a look at an example mutation. Notice that
Sorry, SignFind in the chat is saying you have to define everything. Okay, so I believe this is in response to like where does this stuff get stored? So it's like, I guess this is like a framework or like a pattern that you follow, and you know, you still need to own the database at the end of the day, I suppose. You have to define the person type. The resolver, you have to return a JSON object that matches the person type you defined. There's no magic Yeah, see, this is, I agree. So he's saying there's no magic, which these videos seem to imply. I agree. This seems like magical and fantastic, but like the low level details matter, right? Unless like they just abstract that away from you, in which case I would say like that's a concern if you're trying to build an application that can scale, because that's the first question you ask. It's like, how is this thing going to scale? So I'd like to know like how this is working.
Similar to the query that we wrote before, the mutation also has a root field. In this case, the root field is called createPerson. We also already learned about the concept of arguments for fields. In this case, the createPerson field takes 2 arguments that specify the new person's name and age. Like with a query, we're also able to specify a payload for a mutation in which we can ask for different properties of the new person object. In our case, we're asking for the name and the age, though that admittedly is not super helpful in our example, since we obviously already know these as we pass them into the mutation. However, being able to also query information when sending mutations can be a very powerful tool that allows to retrieve new information from the server in just a single round trip. The server response for the above mutation will look as follows. Notice that exactly as with queries, the server response is shaped according to the mutation that is sent. One pattern that you'll often find is that GraphQL types have unique IDs that are generated by the server. Extending our person type from before, we could add an ID like this. Now, when a person is created, you could directly ask for the ID in the payload of the mutation, since that is information that wasn't available on the client beforehand. Another important requirement for many applications today is to have a real-time connection to the server in order to get immediately informed about important events. For this use case, GraphQL offers the concept of subscriptions. When a client subscribes to an event,
this is what I'm familiar with, and this is why a lot of people love GraphQL, supposedly, or at least the people that I talk to, that they make subscriptions and like passing data around quickly very easily.
It will initiate and hold a steady connection to the server.
Okay, this guy like completely skipped the updating and deleting part. What the hell? We're jumping onto subscriptions now. What is it? Looks like this thing. So I suppose new person here is still some kind of API or still some kind of contract. And then what does this thing do? Subscriptions, give access to real-time data, still appear to require an API definition. I guess the API definition just says like the types and, you know, whatever values or fields that they support.
In this example, the client subscribes on the server to get informed about new users being created. Whenever that particular event then actually happens, the server pushes the corresponding data to the client. In this example, this is the name and the age of the new user, since that's the information that's specified in the subscription payload. Unlike queries and mutations that follow a typical request-response cycle, subscriptions represent a stream of data sent over to the client. Let's assume there are 3 persons that are created by other clients while the subscription is active. The server would then, for each of these persons, push the corresponding data to the subscribed client. Now that you have a basic understanding of what queries, mutations, and subscriptions look like, let's put it all together and learn how you can write a schema that would allow to execute the examples you've seen so far.
Okay, so that's pretty cool. Push to front-end clients. I guess you can achieve the same thing with WebSockets, but I think that's all I want. When events occur on the back end. Love how you're organizing your notes. I should do the same when learning new tech. Yeah, man, it's really helpful. Like writing things down is, you know, it's not the same just watching something sometimes and absorbing it. Although you can. I mean, it depends on the mood. Sometimes I like to just watch and, you know, take notes later and, you know, before bed or whatever. I'm not taking notes, obviously, but to each their own.
The schema is one of the most important concepts when working with a GraphQL API. It specifies the capabilities of the API and defines how clients can fetch and update data. It is often seen as a contract between the server and the client, and in general, a schema is simply a collection of GraphQL types. However, each schema will have some root types that define the entry points for the API. These root types are the query, the the mutation, and the subscription types. Let's now see how we would have to define these types in the schema to enable.
Okay, hold on. What did he say? 3 types: query, subscription, query, mutation, subscription.
All the examples that we saw before. First, to enable the all persons query that we used in the beginning, we need to add a corresponding field to the query type. Notice that we are also adding the last parameter that we were using at some point to limit the number of users that we wanted to retrieve. The type of the all persons field is a list of persons, since this is what the query will return.
Wait a sec. What's the difference? Oh, this is a call and this is a definition, I think. Wait, what? A mutation. Oh, okay, maybe I'm taking the word mutation too literally. I guess mutation is also creation events, right? Not just update events. I think that's how it works. I was thinking of mutation in the context of like you change something that already exists, but I think that the way that they're describing it, it's like any write, regardless of what it does. Yeah, mutating the backend state. Okay, this makes sense.
Similarly, for the mutation to create a new person, we have to add the create person field to the mutation type, since that was the root field that we used when we were sending the mutation. It takes the name and age arguments that we already used before. Notice that the return type of the create person mutation, the create person field, is a single person object. Logically, this is the one that was created by the mutation object. And age person, since
this is a good example. Mutation. I just put some little cheat sheets here. It's basically a CRUD app, right? Query is your read. Mutation is your create, update, and delete. Subscription is some fluff on the end that helps you get some live data. That's cute. So here's our mutation. What am I doing? And this is both a call and definition, right? Yeah, subscription equals WebSocket, exactly, right?
This is what the query will return. Similarly, for the mutation to create a new person, we have to add the create person field to the mutation type, since that was the root field that we used when we were sending the mutation. It takes the name and age arguments that we already used before. Notice that the return type of the create person mutation, the create person field, is a single person object. Logically, this is the one that was created by the mutation. Finally, the subscription type is pretty straightforward. The root field that we used to subscribe to the event of new persons being created was called new person. Consequently, this field needs to be added to the subscription type in our schema. The type of the new person field is person. Let's put it all together. Here we see the full schema that defines all the capabilities of our API. It's based on the model of the person and the post types, and then we also define the 3 root types that we just discussed.
Like this.
It is important to realize that despite having defined the post type in the schema, the API actually does not allow any operations on it at the moment. All we can do with the API right now is to read the list of all persons, create new persons, and subscribe to the event of new persons being created. So the post type at the moment is kind of useless. A more realistic and complete version of the schema would define additional operations for both model types. We could, for example, define a CRUD style API by adding a couple of new fields to the schema's root types. CRUD is short for create, read, update, delete, and refers to the 4 kinds of operations we want to be able to perform on a type. The first thing we would have to do is add another field to the query type to retrieve all the stored posts from the server. This field is called allPosts and looks very similar to the allPersons field that we already have in the schema.
So this is pretty sane, right? Like, this is just your API definitions and just formalizing them in a way. Nothing really shocking. Yeah.
Notice that
Reasonable.
with this setup, all we can do is ask for all the posts and all the persons that are currently stored in the backend, but it's not possible to query individual posts or person objects.
That's true.
Next, we can go and complete the CRUD API for the person type. We can do so by adding 2 more mutations, one for updating and one for deleting person objects. The update person mutation takes an ID that allows to specify which person should be updated, as well as the person's properties as arguments. The delete person mutation, on the other hand, only takes an ID to tell the server which person it should delete. This completes the CRUD operations for the person type. Let's do the same for the post type. All we do is adding the create up.
I get it. You're doing your creates, reads, updates, all right? And you're doing some deletions. Where do you wire this up? That's my question. Like, how does the backend know that they're supposed to send person events there? You know? How does that happen? Anyways, is he going to talk about something different here? Ooh, what's this?
Before we close this chapter, I want to quickly demonstrate to you how you can try out these queries and mutations directly on the How to GraphQL website. When you're going through the written GraphQL Basics chapter, you'll find that a couple of code snippets have this Run in Sandbox button right here. When you click this button, we'll generate your own GraphQL sandbox that you can use to try out the API that we just explained in the slides.
Good enough for me. How do I do that? Where's the button? You lied. What are GraphQL subscriptions? First one. Nice. All right. I guess I'll do the sandbox thing later. Takes all these fields and connects them. Types, resolver, schemas. Let's keep
Welcome
going.
to the fourth.
I like the video. Video's more fun than reading the documentation, I think. But I like to just skim the documentation later, just to make sure I didn't miss something. Anyways.
Fourth chapter of How to GraphQL. In this chapter, we'll discuss some architectural use cases for GraphQL, as well as some major components that you'll find in all GraphQL infrastructures. One thing to note in the beginning is that GraphQL itself has only been released as a specification. This means that GraphQL is in fact not more than a long document that describes in detail how a GraphQL server has to behave, meaning what kinds of requests it should accept and what the response format for these requests has to look like. You can read the specification under the URL that's displayed on the bottom of this slide. If you want to use GraphQL in a project, you'll have to go and build the GraphQL server yourself. You can do that in any programming language of your choice. And you can use one of the available reference implementations for it. But you can also use a service like GraphQL that provides a powerful GraphQL server out of the box. We will now walk.
Okay, that was important. So this is kind of what Signfine was saying before, that this is just a pattern, right? And it looks, okay, now I think I understand what AWS AppSync is. I guess AWS AppSync is the thing, like a managed service to provide you GraphQL functionality instead of having to go and reinvent the wheel, right? Like building your resolvers, building your databases, all that stuff. So I suspect now that that's what these products do. They host your application, and it can conform to the GraphQL way instead of you having to go out and do all that. So that was an important bit. So what is this section? This is, let's call this architecture, I guess is what they're calling it. So GraphQL is a pattern, right? That's effectively what we said. Some products, maybe AWS AppSync, provide functionality to, what do? They provide functionality to support GraphQL queries, mutations, subscriptions. However, GraphQL is technology agnostic and can technically be supported by any combination of backend infrastructure. So I can build my own GraphQL infrastructure right here on my own computer. All I have to do is build a couple servers that do a couple things and boom, done. Okay. Just kind of take some of the glamour out of it, I guess. Let's keep going.
And use one of the available reference implementations for it. But you can also use a service like GraphQL that provides a powerful GraphQL server out of the box. We will now walk you through 3 common architectural use cases for GraphQL. The first one is a GraphQL server with a connected database. This is quite a simple setup that we'll discuss in the next section. Then we have a GraphQL server that is a thin layer in front of a number of third-party or legacy systems and integrates these systems through a single GraphQL API. The third is a hybrid approach of a connected database and third-party or legacy systems that can all be accessed through the same GraphQL API.
These are interesting examples because these are like very real. This is what you would typically face in the real world. I'm just kind of thinking like if I wanted to change, because we use REST APIs where I work. If I wanted to change from REST to GraphQL, like what does that decision mean, right? Does it need my clients need to change? Like how does that work, right? And I guess like it can work to varying degrees. Like you can choose option number 2 here and just give like an interface and still have your current backend systems in place and just kind of provide some level of middleware that allows you to access them in a cleaner way or a GraphQL type way. But is that feasible? Like, is that what people actually do? Or do they decide one day it's like, okay, we're switching to GraphQL, everyone does it, you know? It can't be that, that's too much work.
All these 3 architectures represent major use cases of GraphQL and demonstrate the flexibility in terms of the context where GraphQL can be used. Let's first talk about the use case of a GraphQL server with a connected database. This architecture will be the most common for greenfield projects. In the setup, you have a single web server that implements the GraphQL specification. When a query arrives at the GraphQL server, the server reads the query's payload and fetches the required information from the database. This is called resolving the query. It then constructs the response object as described in the official specification and returns it to the client.
Oh, wait, hold on, I want to get that. Wait, so I was saying that it can be used as a middleware for existing legacy applications, all right? And he just said something here that queries are resolved or are served by resolvers that know how to fetch, with my mouse, know how to fetch the data and compile it according to the original input specification, right? Okay, so this is what Signfine from the chat was saying before. These resolvers are the one where you can add additional logic there. But like, doesn't this give so much power to the client, no? I still feel like I need to see an example of a resolver applying business logic to make me more comfortable here. Like, I feel like the people that love GraphQL are the guys that are like all front-end guys that are like, yeah, we want all the data. We don't want to build APIs. You know what I mean? And they're maybe fighting with back-end guys to build the APIs that they need. And the back-end guys are like, no, you can't do that because like who's going to hold the business logic? Who's going to hold all the rules? How's this thing going to scale? So there's probably like a battle that goes on between them all the time. Now that's like 2 extremes, but I can see that happening very easily. GraphQL would sit at the higher level than your existing REST API. Then it would handle all future requests instead. Yeah, so okay, hold on. Let me draw here. I knew this was a good idea to have a tablet. So how I am seeing this, does this work? Yay, you guys can see that. Delete. So how I see this problem is that like you have your client, right? User. Oh, you can't see that. Damn it. Chopping his head off. Okay. Client. Okay, and then, you know, traditionally you have a REST API here, right? And then you go like this, And then this guy will go like that to these different services and roll it all out, get all the data that you need, and then give it back to the client. But looks like now we have something that looks like this. GraphQL. It goes like that. And then this goes out to different REST API or different services that are hosting data. Alternatively, this thing could have its own data, right? And I guess like there's resolvers somewhere in here, maybe here. Resolvers that are the ones that are like, hey, you give me that and give me that. And eventually that all gets computed back to the resolver, and that goes back to the client. I think that's what I'm getting. Anyways, hopefully that made sense. Let's bring this back into view. All right.
The response object as described in the official specification and returns it to the client. Here you see an illustration of this use case where a client is communicating with a single GraphQL server over the web. It's important to note that GraphQL is actually transport layer agnostic. This means it can potentially be used with any available network protocol. So it is definitely possible to implement a GraphQL server based on TCP, WebSockets, or any other transport. GraphQL also doesn't care about the database or the format that is used to store the data. You could use a SQL database like AWS Aurora or a NoSQL database like MongoDB. Another major use case for GraphQL is the integration of multiple existing systems behind a single coherent GraphQL API. This is particularly compelling for companies with legacy infrastructures and many different APIs that have grown over the years and now impose a high maintenance burden. One major problem with these kinds of legacy systems is that they make it practically impossible to build innovative products that need access to multiple systems. In that context, GraphQL can be used to unify these existing systems and hide their complexity behind a nice GraphQL API. This way, new client applications can be developed that simply talk to the GraphQL server to fetch the data they need. The server is then responsible to make sure it fetches the data from the existing systems and packages it up in the GraphQL response format.
So just going back to like the original example, right? The first thing that I saw where they were making the claim that one API, or to get one piece of data, you need to make 3 different API calls. It's really what GraphQL is doing behind the scenes. But all that they're doing is giving you the ability to select inputs and outputs, right? Seems fairly straightforward, but they're just like really talking this up.
Like in the previous architecture where the GraphQL server didn't care about the database being used, this time it doesn't care about the data sources that it needs to fetch the data that's needed to resolve a query. Here we see the illustration of such a system where the GraphQL server acts as the integration layer for legacy systems, existing microservices, and third-party APIs. And finally, it's also possible to combine the two approaches and build a GraphQL server that has a connected database but still talks to legacy or third-party systems. In this architecture, when a query is received by the server will resolve it and either retrieve the required data from the connected database or from the integrated APIs. But how do we actually gain this flexibility with GraphQL? How is it that it's such a great fit for these very different kinds of use cases? The key to understanding how GraphQL is able to cope with all these different environments is the concept of a resolver function. As you learned in the previous chapter, the payload of a GraphQL query or mutation consists of a set of fields. In the GraphQL Server implementation, each of these fields actually corresponds to exactly one function that's called a resolver. The sole purpose of a resolver function is to fetch the data for its corresponding field. Let's now consider the example of a query that...
Did I just hear that right? There's one resolver per field? So if you do like a person API and you're asking for name, age, something else, you need a resolver for each one? What the hell does that mean? Okay. Resolvers fetch data from the corresponding data stores, can potentially be third-party APIs. Oh, the server has one resolver function per field. You can have, okay, so SignFind in the chat is saying you can have one resolver per query or go really granular and have one resolver per field. Okay, that makes more sense. I wish you just never even said that. That just confused the hell out of me.
Of a resolver function is to fetch the data for its corresponding field. Let's now consider the example of a query that is sent to a GraphQL server and think about the resolver functions that are required to properly respond to that query. Here, we send a query to ask for the user that's identified by a particular ID. In the payload of the query, we specify the information that we'd like to have returned by the server. In our case, that's the user's name, as well as their first 5 friends, of which we are requesting the name as well as the age. The first resolver that would have to be implemented is for the root field of the query. In that case, that is the user field. The resolver function for the user field takes a required ID as an argument and potentially returns a user instance. The return type is nullable since we don't know that the user with the provided ID actually exists. Notice that the function signatures are just pseudocode to illustrate the idea behind resolver functions. The actual function signatures of your resolvers that you write for your GraphQL server implementation might differ depending on your context. We then can add a resolver function for the name field. Name is a field on the user type and doesn't take any external arguments that can be provided in a query. However, in order to be able to find the name of a user, the server needs to know which user that is. The resolver function thus takes a user as an implicit argument. The return type of this resolver is a non-nullable string, which corresponds to the type of the name field in the GraphQL schema. Next, we can add the resolver function for the age field. That's analogous.
But okay, you give an ID, you get a user. You give a user, you get a name, string. You give a user, you get an age int. But it's all just coming from this. Right? Like what's the point of that? Maybe I'm missing something, but I'm sure there's an explanation.
To the name field, except
it's probably about like flexibility or something. That's like, you know, this field can always be found if given a user.
That it returns an int instead of a string. And finally, the friends field in the query payload can be resolved by a corresponding function that takes an optional parameter called first that can be provided in a query, as well as the implicit user argument, since friends also is a field on the user type and the server needs to know whose friends it should fetch. This function returns a list of users. The last concept that we'll cover in this chapter is the concept of a GraphQL client. GraphQL is a particularly great technology for front-end developers, since it completely eliminates many of the inconveniences and shortcomings that are experienced with REST APIs, such as over- and underfetching. Complexity is pushed to the server side, where powerful machines can take care of the heavy computation work. The client doesn't have to know where the data that it fetches is actually coming from, and can use a single coherent and flexible API. This provides an opportunity to build new abstractions on the front end to make it even easier for developers to interact with an API. Let's consider the front end to make it even.
So this is how I feel right now. That GraphQL is for front-end developers because it's giving them the control to put all your business logic there. By just defining this flexible data model where you can get anything you want, who owns the logic now? Is it the front end or is it the back end? These are interesting questions. Client is agnostic to which database, data source, data is coming from. Resolvers satisfy a wide variety of client queries. Possibly puts too much power into the hands of the front end. Open question. How does business logic work in this model? Digital dev boss. Yes, this idea confuses me. It almost feels like GraphQL, like Apollo is a middleman server. Yeah, that's pretty much it. Apollo, AppSync, they're just sitting in the middle and fulfilling the specification. And I don't know enough about them, but I suspect that they also like provision the databases on the back end too, so that you can just say create a new type, like a person type, and it'll pick whatever database depending on the specification in the schema. It probably just picks the best database type for whatever you're trying to do. So for instance, if you're just like, you have a schema that says you have a person model and your queries are always like by IDs, because that's determined straight up in the definition of the APIs. Well, then it probably just makes more sense to use Dynamo then, right? Because Dynamo is good for by ID lookups. Whereas if you have something where you have a lot of nests in your data model, like, a person has posts and a post has an author and an author has, I don't know, something else where it's many to many to many and all these different combinations, then it makes more sense to use RDS or Elasticsearch. So it probably just like looks at the data model and then determines like everything. But on the same token, like you have the ability to choose that too. Client never cared about where the data was coming from, so there's no point in stating that in the video. Yeah, that's true. Whether GraphQL, yeah, whether GraphQL or Rust. But I guess it gives them more flexibility to get more of what they want easier. I don't know like what the security landscape looks like for GraphQL, but that's something I'd be interested in learning about.
Easier for developers to interact with an API. Let's consider the major change that's introduced with GraphQL in going from a rather imperative data fetching approach to a purely declarative one. When fetching data from a REST API, most applications will have to go through the following steps. First, they have to construct and send the HTTP request. For example, using the fetch function, response has to be stored locally, either simply in memory or maybe persisted. And finally, the data can be displayed in the UI. With the ideal declarative data fetching approach, on the other hand, a client shouldn't be doing more than the following two steps. First, it has to describe its data requirements, and then it can display the information in the UI. Everything that's in between should be handled by the GraphQL client. All the lower level networking tasks, as well as storing the data, should be abstracted away, and the declaration of data dependencies should be the dominant part in the data fetching process. This is precisely what GraphQL client libraries like Relay or Apollo will enable you to do. They provide the abstraction that you need to be able to focus on the important parts of your application, rather than having to deal with the repetitive implementation of infrastructure and data fetching logic. This was it for the 4th chapter of how to...
All right, guys, we're pros. That was pretty cool. Wait, there's more though. We're going to watch more. Don't you worry. There's more to this stream. Sign fine in the chat. Yeah, with issues like security, GraphQL may make it slightly easier for the front-end devs, but introduces more headaches for the back-end devs. That's exactly how I feel. I just kind of want to skim through this to make sure we didn't miss anything. So he talked about like a bunch of different use cases. This is the one where you have like a middleware to connect with existing systems. Oh, this is the hybrid approach where you can have your own database and also other APIs. Resolver functions, these are basically the things that do all the work. They're the ones that go and retrieve your data and put it all together based on the input documents. Client libraries. I don't think I missed anything here. So are these like SDKs, like Relay in Apollo? Like you connect it to your endpoints, and maybe someone in the chat knows. Like what is Relay in Apollo? Is it just like an import and I use it to interact with my GraphQL servers? I don't know. Let's see. Function that a GraphQL client uses to resolve a query on the function that solves all your problems. I want it to be this. They're responsible for fetching the data. Yay. Okay. I want the advanced topics. Oh, Apollo and Relay are the implementations of GraphQL. I see. Okay, more on clients, more on servers, and 4 more topics. Nice. Oh, no videos. Okay. Let's go through this. Working with the GraphQL API on the front end is a great opportunity to learn new or develop new abstractions and implement common functionality on the client side. Infrastructure features that you probably want to have in your app. Send queries and mutations directly without constructing HTTP requests, of course. View layer integration, caching, validation, and optimization. Nothing stops you from using plain HTTP to fetch your data and shifting all the bits yourself until the right information ends up. GraphQL provides the ability to abstract away a lot of the manual work. Okay, so Apollo is the client here. Apollo Client, which is a community-driven effort to build a powerful and flexible GraphQL client for all major development platforms. Got it. Second one is called Relay, and it is Facebook's homegrown GraphQL client that heavily optimized for performance and is only available on the web. What do most people use? SignFine, if I use Apollo, does that mean I have to use their, like I'm assuming it's a server language as well, right? Or can their client connect to AppSync, I guess is my question. I would assume. It's client and server. Huh. I wonder how you set that up. Okay, maybe that's something to look into later. Okay. Send queries and mutations directly. This is kind of boring. So now they're talking about integrations with props and React to do automatic UI refreshes. That's cool. I don't really care about this stuff too much. Caching results. You want to maintain that. When caching data, the intuition is to put information that's fetched remotely into a local store from where it can be retrieved later. Simply put the results of the GraphQL queries into the store and simply return them whenever the same query is sent. Turns out this approach is very inefficient for most applications. Put the results, okay. Is to normalize the data beforehand. This means that the potentially nested query results get flattened and the store will only contain individual records. Ah, okay. That's a neat idea. The idea here is that in a lot of caches, to explain this a little more, let's get the pen out again. So what a lot of caches, including what DynamoDB Accelerator does, is like they hit the cache layer. Wait, can you see that? Yeah. So like a request comes in, hits the cache layer, right? And say it's a query, right? So you have like an ID that's being passed in. This will, you know, get a whole bunch of results. 3, 4, 5 results, right? And now, like your caching layer, what it'll do is it'll cache this ID to an array of all the results, right? Problem is when one of these things change on the back end, it doesn't change in the cache. It needs to be wiped, but it doesn't in most implementations. But it seems like what they're saying here is that they normalize the data beforehand. Oh, it's still on screen. And they flatten it out. So they don't do this like one-to-many caching. They just flatten all these objects out here. So if there were like 2 or 3 different objects in there, they would all get flattened out. And all the fields would be in here. So all the fields from each of these objects and each of these IDs can be reused later. At least I think. That's how I'm interpreting that. Can you review the security issues that arise for backend devs again at some point if you get the chance? I missed that part. I think the concern is that you're opening up your backend data model to, in a lot of cases, whatever the client wants, and you don't have a lot of control over what the client is trying to do. It's basically like you're giving the keys to the castle when you use this. Now, that being said, you can restrict your schemas so that you're only serving different fields back. And I think it's okay. Like, I don't think the security issue, like, it may be overblown, but I'm kind of spidey sensing some problems here. I can't quite put my finger on it yet. Caching GraphQL response is pretty difficult because it's a post request compared to REST. That's true. Okay, where were we here? Since the schema contains all information about what a client can potentially do with the GraphQL API, there's a great opportunity to validate and potentially optimize. UI code and data requirements side by side. Okay, I think I'm done with this chapter. I'm just skipping that too. Oh, that's a good point. Sign fine. You can like nuke a GraphQL server. Oh man, that's a really good point. That if you know, like say I'm someone that wants to bring down a GraphQL server. If you know in advance that certain operations are very heavy, you can just make a ton of those operations. For instance, like deeply nested operations. You can make a ton of those and just kind of blow away the back end. And then I wonder, how do you tune your backend for this? Like, at least when I'm building that backends, you define like what hardware you're picking based on the type of query patterns that you're anticipating and what your limits are. So if you're working on a service that has like bulk request APIs, like where they give you, you know, criteria for something and then you need to get everything back, you're probably going to be like heap bound, memory bound, right? Because you're going to have to grab a lot of that stuff, throw it on your heap, process all that all through, and then return it back. But like none of that is talked about here, right? It's always just like the backend's problem. It's the server's problem. So like I have questions on scale, many questions on scale. Anyways, server. Okay. GraphQL is often explained as front-end focused API technology because it enables clients to get data in a much nicer way than before. But I knew it. I knew why all the front-end guys love this thing. I used to work with a front-end guy, like he was a front-end god. And he was always just like, can we use GraphQL? Can we use GraphQL? And I never understood it. I'm like, what's wrong with what we're doing? You know? This is before I really knew anything about it. And he couldn't really explain it, but now I get it. It's because he just didn't want to deal with rules on the back end. Anyways. But the API itself is, of course, implemented on the server side. Derp. There are lots of benefits to be had on the server as well because GraphQL enables a server developer to focus on describing the data available rather than implementing and optimizing specific endpoints. That's like, sure, that's true, but that's actually not a good thing. It enables the server developer to focus on describing the data available rather than implementing and optimizing specific endpoints. Okay, maybe the implementing part isn't always a good thing, but this is a good thing. Like you specify how your servers are built, right? Based on the requests that are coming in and the APIs that you define. If you're defining all these flexible APIs that people can use however they want, how do you ever build an API that, or build an architecture that's scalable and safe and predictable? Maybe I'm missing something. Anyways, I'm taking notes here. What do I want to say? I'm going to put this in quotes. Enables the server developer to focus on describing available data rather than implementing and optimizing endpoints. Questionable. Okay. GraphQL doesn't just specify a way to describe schemas in a query language to retrieve data from those schemas, but an actual execution algorithm for how those queries are transformed into results. This algorithm is quite simple at its core. The query is traversed field by field, executing resolvers for each field. So let's say we have the following. So query that has an author. Okay, we're getting get author by ID, right? Then we have an author, and we're getting all the posts. Oh, wait, this is a type author. The front end guys love it because if schema changes on the back end, the front end doesn't silently start to fail. The schema changes on the back end, the front end doesn't silently start to fail. True, true. Rather, GraphQL will be loud and clear about what field is not getting the right fields, or the right data types. Ah, okay. I'd like to see that in action. The following is a query we would be able to send the server with that schema. Okay, so this is basically saying that your queries are, the possibility of your queries are defined by your data models, right? If you don't have a data model that links these objects, it doesn't make sense to make a query that has an implicit link between those objects. Okay. First thing to see is that every field in the query can be associated with a type. So this is describing the resolver process. Now we can easily find the resolvers in our server to run for every field. The execution starts at the query type and goes breadth first. This means we run the resolver for query author first, okay? And then we take the result of the resolver and then pass it to its child. Okay. As the next level. Oh, cool. So it kind of like compiles down to like a little bit of pseudocode. At the end, the execution algorithm puts everything together into the correct shape for the result and returns that. Most GraphQL Server implementation will provide default resolvers, so you don't have to specify a resolver function for every single field. Oh, okay. In GraphQL.js, for example, you don't need to specify resolvers when the parent object of the resolver contains a field with the correct name. May need to read that later. Batched resolving. One thing that you may notice about the execution strategy. Okay, wait, hold on. There were some things there. Resolution of queries. Does BFS on the data models to resolve. Pulls data one by one, aggregates into shape, returns to client, I think. For example, if you have a resolver that fetches from a backend API or database, that backend might get called. Oh, okay, this is the question that I was asking before. That backend might get called many times during the execution of one query. Let's imagine we wanted to get the authors of several posts like so. So query post title author, okay. If these posts are on a blog, it's likely that many of the posts will have the same authors. So if we need to make an API call to get each author object, we might accidentally make multiple requests for the same one. Yeah, okay. That's exactly what I was wondering. How do we solve this? By making our fetching a bit smarter. We can wrap our fetching function in a utility that will wait for all of the resolvers to run, then make sure to only fetch each item once. Who runs this? By making our fetching a bit smarter, we can wrap our fetching function in a utility and wait for all of the resolvers to run, then make sure to only... Oh, okay, so this is in the resolver itself? I don't really get that part. Author loader. Can a resolver have resolvers? Maybe that's the question I need an answer to. Sorry, there's loud motorcycles there. You guys hear what I have to live with? I'm moving in a month. Thank goodness. Okay, so how does this work? In JavaScript, the above strategies can be implemented by using a utility called data loader, and there are similar utilities for the languages. Where does this go? Like, it must go on the server, right? It must go in the resolver. We're on the server section. Okay, I have an open question here. A resolver doesn't have another resolver, but GraphQL can delegate sublogic to lower level resolvers. Oh, okay. Then maybe that's where this is going. Like, this is probably the top level thing. Like what's described here, rather. It's probably the top level thing, and then invoking something and doing some clever logic. Okay. Which statement about GraphQL servers is correct? Oh god. A single record is never fetched more than once for a given query. That's not correct. Query field to resolve. That's not correct. Can be defined. Resolvers can be defined on a field granularity. I think that's correct. I think it's this. Yay. Okay. More GraphQL. Oh, look, there's a security section. Someone was asking, Digital Dev Boss, I think you were asking about security. So we're going to get there in a little bit here. Fragments. What are fragments? Fragments are a handy feature to help improve the structure and reusability of your GraphQL code. A fragment is a collection of fields on a specific type. Okay, so it's a subtype, basically. It's a sub-collection. That's neat. Let me write that down. Fragments. Basically, like, how do I, let me think of these words. Sub-collection of fields that belong to a particular type. Here we could represent all the information that relates to the user's physical address into a fragment. Now, when writing a query to access the address information of a user, we can use the following syntax to refer to the... Oh, I see. So we don't need to write this every time. Got it. Okay. Partials, yeah, that's a good way of putting it. Let me, you know what? Let me just take a thing of this. Allow for code reuse, and I want to get this as well. So that queries don't need to repeatedly define groups of fields that they want. I think this is what the ... is, right? ... denotes fragment in a query. Okay. Parameterizing fields with arguments. In GraphQL type definitions, each field can take 0 or more arguments. Similar to arguments that are passed into functions in typed programming languages, each argument needs to have a name and a type. In GraphQL, it's also possible to specify default values for arguments. As an example, it's considered part of the schema we saw in the beginning. All users, okay, we saw this before, true. We can now add an argument to the all users field that allows us to pass an argument to filter users and include only those above a certain age. Oh, these are the weird things that we were seeing. Like filters, basically. You can also specify default values so that by default all users will be returned. Okay, what are these called? Parameterizing fields. You can parameter, is that right? Yeah, I think so. Fields with, like, I want to call them filters, or I don't know. I don't know if filters is the right word. Is filters the right word? Maybe. I'm just going to call them filters, i.e. greater than 30 years old, as part of your query request. Those values end up in the arguments of your resolver function. Got it. So it just uses that to perform the job. Okay. One of GraphQL's major strengths is that it lets you send multiple queries in a single request, right? However, since the response data is shaped after the structure of the fields being requested, you might run into naming issues when you're sending multiple queries asking for the same fields. Why is this a problem? Major strengths, I read that. This will produce an error in GraphQL Server, since it's the same field but different arguments. The only way to send a query like that would be to use aliases. Same field but different arguments. What? Oh, because this thing doesn't take a list, or doesn't. Oh, it's a single. Okay. So this query API only takes an individual. So it looks like you need to use some weird annotations here to make this work. I guess alternatively, you can define a new query API that takes in a list of strings and returns a list of users. But this seems like a way to not do that. Okay. Advanced SDL. The SDL offers a couple of language features that weren't discussed. Object and scalar types. Okay. So I'm looking like a real programming language here. Concrete types, so your usual primitives. Properties, which are composable. Okay. We have enums. That is great. Interfaces, eh? Huh. Can be used to describe a type in an abstract way. It allows you to specify a set of fields that any concrete type which implements this interface needs to have. Now this is cool. Huh. This requirement can be expressed by defining an interface with this field and then making sure all custom types implement it. That's kind of cool. Man, there's a lot of depth to this. Depth. Union types can be used to express that a type should be either of a collection of other types. They are best understood by means of an example. Okay. When is this useful? Isn't this the same as... Maybe I don't understand. Like, this must exist for a reason. I just don't know why you would need to do this yet. Query where we can ask to retrieve information about a child but only have a person type to work with. How do we know whether we can actually access this field? Right? Conditional oh my god. Oh, then you need to start worrying about the types within your queries? Holy hell. Person query with field that is either string or int. Oh, okay. That makes sense. Maybe a type you created. Got it. Okay, maybe this example is just a little bit more complicated. What else do I want to put here? What section was this? Contains interfaces. I don't think it's classes, right? They didn't say they have classes. Oh wait, what are the other things we said? We said you can't query the same thing with, wait, what did we say when we were saying about the IDs? It was this example. Oh yeah, you can't query the same API with different arguments. The same API with different arguments in one request unless you, I don't even know how to describe this, do some silly business. In brackets, just make a new API that takes a list of, oh sorry, we're running off page here, list of strings and returns list of objects. Also learn that there's interfaces, primitives, enums, I want to put this on a different section. And union types. Useful to define. Useful to define optionals. Ors. Okay. Oh god, I'm going to fail this one. Which of these statements is false? Aliases can be used to name the result for multiple queries. I think that's true. Pretty sure that's true. Fragments are useful for the structure. That's true. Every field in a GraphQL type can be associated with 0 or more arguments. I think that's true. Date type. I don't think they ever mentioned this. Oh, okay, there we go. Okay, tooling and ecosystem. Ooh, this looks cool. Okay, GraphQL ecosystem is growing at an amazing speed right now. One of the reasons that this is happening is because GraphQL makes it really easy for us to develop great tools. In this section, we'll see why this is the case and a few amazing tools we already have in the ecosystem. If you're familiar with GraphQL basics, you probably know how GraphQL's type system allows us to quickly define the surface area of our APIs. We know that. An amazing thing, GraphQL allows clients to ask a server for information about its schema. Ooh, I like this. I like this a lot. This is great for discovery. Introspection. So clients can ask servers about their schema to learn about the APIs they support. This seems like a security problem too, no? Like the old way that you would have to do this, you'd have to like decompile apps to figure out what the endpoints are and then like trying to figure out what all the APIs are doing. But now you can just ask a server, hey, what do you support? Here you go, give me this, I'll give you that. Done. So I think, Wayne, you were asking about security problems. There's another one. But we'll probably get to that section soon. Yes, security issues. The designers of the schema already know what the schema looks like, but how can clients discover what is accessible? We can ask GraphQL for this information by querying the schema meta field, which is always available on the root type of a query. Okay. Types. Cool. As you can see, we queried for all the types of the schema. We got both the object types. We defined the scalar types. You can even introspect the introspections. Nice. Okay. I think I get it. I don't think there's much really to see there. As you can see, introspection is an extremely powerful feature of GraphQL. We've only scratched the surface. The specification goes into much more detail about what type of fields that are available. Provide amazing features. Okay. GraphQL Playground. Okay, opening that in a new tab. We're coming back to that later. For interacting with GraphQL API, features an editor for queries, mutations, and subscriptions, equipped with auto-completion validation, as well as documentation. You work with multiple graphs side by side. Cool. So can this connect to anything? Oh, it's just a website. Failed to fetch schema. Oh. Help. I'm just clicking things now, guys. Something's not working. Okay, I gotta look into this later. I really want to get this working though. I kind of want to try it. What mechanism is used by most tools to discover a GraphQL type system? Introspection. Security, here we go. Okay, this is a pretty long one too, eh? I think this is the last section. GraphQL gives enormous power to clients, but with great power comes great responsibilities. Teehee. Security. Since clients have the possibility to craft very complex queries, our servers must be ready to handle them properly. These queries can be abusive queries from evil clients, or may simply be very large queries used by legitimate clients. In both cases, the client can potentially take your GraphQL server down. There are a few strategies to mitigate these risks. We'll cover them in this chapter. Timeouts. First strategy, and simplest, is to use a timeout to defend against large queries. This strategy is the simplest since it does not require the server to know anything about the incoming queries. Server can be configured with 5 seconds timeout. This is tricky. Hold on, I want to get some notes down before I flush that out. So basically we're acknowledging that large queries by bad actors can possibly affect our system, right? That's a known thing. So their suggestion is to use queries. The reason why their suggestion is to use timeouts as a potential solution. The reason why timeouts don't always work is because the timeout durations need to match both on the server and the client so that they're timing out at the same time. In addition to that, if you make a call to a server and then a server makes calls to other APIs and they have a longer timeout duration, you need to make sure that when your server's timeout limit is hit, that all of those requests to those other servers get canceled and get terminated and all the connections get cleaned up. So there's like some problems there. That's why I don't really think that just saying using a timeout's a good idea. It can screw you is what I'm trying to say, unless you're careful. Simple to implement. Okay, so one mitigation. Actually, I think these are all mitigations. Timeouts. Very simple. See, cutting connections after a certain time may result in strange behaviors. Strange behaviors, i.e., the client thinks that the request is still being fulfilled, but the server has already kind of given up. The client is still can be waiting. Or like bizarre scenarios like that, where you have like one person still holding their hand out, but the other one is basically already taken their hand away. But the person with their hand out doesn't know it yet. As we covered earlier, clients using GraphQL may craft complex queries. Since one GraphQL schemas are often cyclic graphs, this means a client can craft a query like this one. Holy hell. Post, author, wow. If we want, we can prevent clients from abusing query depth like this. Knowing your schema might give you an idea of how deep a legitimate query can go. This is actually possible to implement and is often called maximum query depth. These are just mitigations though, right? See, this is another big negative of GraphQL is like you're controlling this stuff. Okay, how do I phrase this? The argument that they are trying to make, if you use this specification, is that it simplifies your development experience. But now you need to worry about all these other things like this. Now you need to anticipate how people are going to be querying your application and think about these things like depth, like timeouts. Well, timeouts you should always have, but like something like this, like who the heck wants to think about this? No one wants to think about this. This is horrible. So sure, you're simplifying your development experience, but you're opening yourself up to issues. You're opening yourself up to other different types of problems. Sure, they may not be the same problems that you were facing in the RESTful world, but they are other very real problems. So that catch-all sales pitch that says GraphQL simplifies your life is, you know, very naive to say the least. But anyways, okay, so they're suggesting here to analyze the depth of queries to detect when a query is malicious. And I'm using the word detect very, like, how do you even detect this, right? Like, how are you gonna, if you're a back-end service owner now, you're giving all the abilities to the clients. Like, how can you even know now how your clients are going to be doing? Like, how deep they're going to be going? What, you're going to have to analyze your resolver functions to see what they're doing before you can implement some kind of detection algorithm that looks at depth? See what I mean? This isn't straightforward. Anyways. Okay. Since goes the opposite direction of keep it simple, stupid. That's for sure. Depth alone is not enough. Derp. For example, a query requesting an enormous amount of nodes on the root will be very expensive, but unlikely to be blocked by it. Yep, exactly. That's another problem. Touché. Sometimes the depth of a query is not enough to truly know how large or expensive it is. That is true. In a lot of the cases, certain fields in our schema are known to be more complex to compute than others. Query complexity allows you to define how complex these fields are and to restrict queries with the maximum complexity. What the heck is this? The idea is to define how complex each field is by using a simple number. A common default is to give each field the complexity of 1. Okay. Three is the complexity of this query. If we were to set a max complexity of 2 on our schema, the query would fail. What if the post field is actually more complex than the author field? We can set a different complexity. This is terrible. This is bad, man. I never want to maintain a thing like this in production. I think I'd lose it. How do you, like... What does this even mean? What does 5 mean? What do these numbers mean? How do you even assign a number? You know? Oh dear. Covers more use cases than a simple query depth, rejects queries. Yeah, that's understatement of the year. Hard to implement perfectly. No. Expletive is what I wanted to say. If complexity is estimated by developers, how can we keep it up to date? Very good question. How do we find the cost in the first place? Mutations are hard to estimate. What if they have a side effect that's hard to measure, like queuing a background job? Yep. Okay, so there's this notion of complexity. Which is basically make a judgment call and assign a query with a magic number. If the magic number is too big for a query, fail it. Sorry, assign a field. Right? That's effectively what they're saying. I don't know how else to put it. It's basically what they said. Throttling, excuse me. Wow. The solutions we've seen so far are great to stop abusive queries from taking your servers down. The problem with using them alone like this is that they'll stop large queries but won't stop clients that are making a lot of medium-sized queries. In most APIs, a simple throttle is used to stop clients from requesting resources too often. GraphQL is a bit more special because throttling on the number of requests does not really help us. Even a few queries might be too much if they are very large. In fact, we have no idea what amount of requests is acceptable since they are defined by the clients. So what can we use to throttle clients? A good estimate of how expensive a query is the server time it needs to complete. Oh no. We can use this heuristic to throttle queries. With a good knowledge of your system, you can come up with a maximum server time a client can use over a certain time frame. Oh no. My head hurts now. So, are they saying to sum up the time? No, that's not what leaky bucket is. Okay, hold on. Let's read the example before I lose my head here. Let's imagine our maximum server time set to 1,000 milliseconds. That client's gain 100 milliseconds of server time per second, leak rate. By the way, I have a video coming out on this soon. Person says, "You're doing such awesome work with this channel. Thank you so much." Thank you for the kind words. I appreciate it. And this mutation takes on average 200 milliseconds to complete. In reality, the simple time may vary, but we'll assume it always takes 200 milliseconds to complete for the sake of our example. It means that a client calling this operation more than 5 times within 1 second will be blocked. After 2 seconds, okay, this is just a classic leaky bucket algorithm. Basically, like usually use tokens. It's like tokens are dripping into a bucket and you get a token. If you use a token to make a query, and if there's no tokens on the bucket, you can't make your query. And they're using like the accrual of time to denote this. Usually it's you do this by like requests themselves and not time. There's other rate limiting and throttling algorithms too, like the token bucket algorithm, the leaky bucket algorithm, the time window algorithm. Learned a lot in the past few days. That's awesome, man. Keep on learning. Never stop. And now you can learn GraphQL. Okay, so another option is throttling based on time sum. Okay, another reason that this is kind of dumb is that like, okay, this makes no sense, right? What if, okay, they're basically saying that, oops, is my stream down? No, you guys are here. Sorry. This is kind of dumb because what they're suggesting here is to use the accrual of time to determine throttling. So how can you tell now, like what happens if the traffic volume from a client doubles, right? And the duration of the query stay the same, right? So let's say in this example, we have, let's take an example here. Actually, I'm getting my pen back. Forget that. Where is it? So what they're saying is, let's simplify a little bit of this a little bit. Let's say you have a bucket size of 300 milliseconds, right? And they're saying that, you know, you can throttle based on like some time unit, so some period of time, right? Maybe this is like 1 second, whatever it is, right? But we're saying in this period of time, you can't go over 300 milliseconds worth of computation, right? So that means if you have 3 different requests that are coming in, let me actually take a different color here. Yellow. 3 different requests that were coming in, right? This one, and they're all even. This one, right? First request, second request, third request, right? This number works, right? But now what if you get your traffic doubles, right? So now you have even more. So what do, right? You need to bump this number up right away. Like what if you're getting 6 requests within 300 milliseconds now? Now 3 of them will start failing, right? So like this model doesn't work. I don't know why they're suggesting it. But we will press on. I just found your channel tonight, but I agree your content is great. Thanks, man. I do my best. I've been making videos for a while, but it's really been like picking up steam lately. I don't know why. I'm curious how you found the channel. I'm always like trying to figure that out. Is it through like word of mouth or just like suggestions on YouTube? I don't even know these days. Okay, anyways. So throttling based on time sum, this is bad. Don't do this. DynamoDB is how I've been found. Nice. I have a lot of videos on Dynamo. I was Googling AWS service tutorials. Nice. Throttling based on query complexity is a great... Okay, so this is like better, but now it's 2 layers of stupid. That was kind of mean. Okay, I guess, yeah. Throttling based on complexity, sure. Throttling based on less bad. Oh, you were looking for Redis. Oh yeah, I did make a couple videos on that a while ago. For whatever reason, my Redis videos never took off. I thought they would do well. I don't understand YouTube sometimes. Okay, so we know this is a cost 3. We have a maximum cost of 9. Our clients run this query only 3 times. Yeah, so I think this is clear what this is doing, that you're summing up the complexity of the query as if it's like your number of tokens that you are consuming, and your backend is basically renewing tokens at a rate. And the more complex queries you do, the more they consume. And so the less queries you can do. Keep in mind, these are magic numbers that probably make little sense and are hard to predict and will make someone want to rip their hair out. But anyways. Many approaches. All right, cool. What's this? Is not a valid way to defend against abusive. Adding more servers. That should be a way, though. I guess you don't really think of that when you're kind of working with this stuff. It's all like front-end modeling. I love your videos because they don't follow the rule of Wadsworth constant. No, I never heard of Wadsworth constant. The ones... I had no idea. Nice. Okay. Common questions. What are we doing now? Error handling, offline usage. Is it a database technology? This is a misconception. It's a query language. I think we learned that it's a specification. It's not for just React JavaScript developers. How to do server-side caching. So basically it's just like a specification and then you kind of implement it in whichever way that you want to implement it, right? Or you can go with some of these pre-built packages that have a bunch of this stuff already figured out. Good luck on your study and thank you so much for your gold content. Thanks, man. Good luck on your endeavors as well. How to do error handling. A successful GraphQL query is supposed to return. Okay, so these are just like additional facts. It uses probably this. There we go. Choosing the right tutorial. Congratulations, you made it through the first part of the how-to GraphQL and learned all you need to know about how to build an actual app with GraphQL. In the following section, you can choose from one of the many hands-on tutorials we created for you. All tutorials will start from scratch and teach you how to build a fully fledged Hacker News clone, depending on what you want to learn. You can either choose a tutorial from the front end or the back end tracks. Expo. I want to try that playground a little bit. That seemed like a good idea. How do I get to there? Okay, hold on a second. GraphQL Query. GraphQL Sandbox. Or do I call this thing sorry, I'm just on my other monitor right now. GraphQL Online Editor. Oh my gosh. Someone link me to a GraphQL editor, please. Anyone. Or Playground. I am doing it. Here, I'll just bring this here. What's this thing? I don't have one. This is ridiculous. I don't want to build anything. I just want to try it. Oh, is it? No. Interesting. I don't know, guys. If you figure out a way to find a playground, let me know. I'm going to be doing another video probably at some point, probably a live one on one of these tutorials here. I don't know which one. Actually, you guys let me know. What do you guys think I should do here? I want to decide before next time. Keep in mind, I'm really bad at Node.js. I know Python better, or Java is good, but and I don't really want to do front end. Actually, you know what? Let's change up. Should I do front end? I don't know. Wait, what are the options? Ooh, this looks nice. This looks nice. Ooh. Oh, Python? API. Okay, got a link. RB saved me. Whoa. What is this? This is impressive looking. Holy cannoli. Okay, well, I'm bookmarking this thing. Online GraphQL editor. Let's make this puppy bigger. This is just like a little too complicated for me. Can I just have something simple? Query root. Holy smokes. This is like an RDS nightmare. Oh my gosh. Does this mean optional? This is sick though. I'm not gonna lie. Like the fact that you can like click a button and generate this is like blowing my mind. I can't tell you like how much this helps with maintaining your documentation of like how systems work and stuff. Like honestly, sometimes that's half the battle. But it's not like I can like edit things here, can I? I don't think so. But it's pretty cool to get an idea. Oh, Digital Dev Boss found one. Let's try this one out. Ooh. Ah, here we go. Here we go. This is it. Okay. What are the other attributes? You will see intelligent type heads. Can I just like start doing things? Ah. What does this do? I don't know what I'm doing. What are some other things here? Like, how do I know what is inside countries? You know what I'm saying? Oh, you can change the endpoint at the top. Oh, cool. Oh, wow, you can connect to anything you want? That's pretty sweet. Well, let me out. Oh, here we go. Okay, so... Oh, okay. Hold on, so... Let's try this. Oh, you guys probably can't see this very well, can you? Whoa. That's looking better. Okay, so we have languages, right? And then... Wait. How did this look again? Languages. And then... Can I just put language in here? Or is it lowercase? Oh, you need to give it ID. Language filter input. No attribute. Is that what you're saying? Oh, wait, okay. Is that valid? I don't think that's valid. Check the schema first. Type. Filter. Oh no, I pressed back. Okay, where was I? Sorry, okay. So I was trying languages. Okay, so if I'm reading this right, it takes in a language filter input and what the hell is this? Oh, I don't want to do this. This is complicated. Let's try something easier. Okay, how about this one? Continents. Now, I can't remember the syntax. Do I need to like pass in ID? 1. And name. Wait, does this even need it? How do I run it? Where's the run button? Oh. Hey, it worked. Hooray. Oh, that's what those links are. Thanks, Arby. Whoa. Oh, nice. Oh, this is a nice editor too. I like this one. Oh, this is great. Let me try this other one you did. Oh, same thing. This is a nice editor too. Okay, so ID 1, then you're asking for the title and thing back. That makes sense. But this is kind of cool. I'd like to define my own schema with everything, just like kind of, I'll probably do one of those tutorials here because like I feel like I actually need to do it now. I'll probably do the Java example first because that's what I'm more familiar with. It's going to be easier for me. Anyways, let's just go over the stuff that we learned today. Like what's the TLDR, right? Okay, so GraphQL, it's being sold as the best next thing that's going to solve all of REST problems. I disagree. I don't think that's true. I think it creates a lot of new problems that REST developers don't face or face less of. I don't think it's as simple as saying that one thing is better than the other. Now, there's definitely things that GraphQL is better, like minimizing network bandwidth because it can allow you to select certain fields that you want as part of your response. So that is definitely a pro. The fact that you get pretty much built-in WebSockets with subscriptions is a very big plus because it makes it very easy to implement real-time applications. So like I said, overfetching, underfetching is solved and you get a lot more flexibility. Also, it adds a lot of power into the hands of the front end, which is both a blessing and a curse. Depends how you look at it. I see it from a back-end perspective as a maintenance and scaling nightmare. That's my opinion. Now, core concepts, STL, schema definition language. It's got this kind of like JSON-like language that you can use to define what your types and your queries and mutations look like. 3 main components: queries, mutations, and subscriptions. Queries are your reads. Mutations are your creates, updates, and deletes. And subscriptions are your WebSockets. You can define schemas for each of these things that are kind of like your APIs that have a contract with what you can put in as options and what you can get out. It uses the STL to kind of communicate that. So this one here is an example. Oh wait, just want to make sure this is all viewable. This one right here is an example of a call, so a mutation to modify a person or create a person rather. His name is Bob, his age is 36. And this is the definition of the contract of the type for the mutation, and it's a create person operation. Makes sense. GraphQL likes to peddle the fact that it's generic and flexible. I agree, but that's just because it's a specification. It's not actually a product at the end of the day. You have to use something else like AppSync, apparently something like Apollo, to deliver and like handle the resolvers, handle the databases, handle all that stuff that still needs to exist on the back end. Using products like that, you get to abstract away some of the complexity of building and maintaining those things. Optionally, if you're a power user, you can implement your own resolvers, implement your own kind of query handling based on what's passed in, and hook it up however you want. It's really just a pattern, and you can follow it however you want using any technology you choose. It's transport layer agnostic, it's database agnostic for the same reasons I just mentioned. Resolver functions are where most of the work seems to get done. They're the things that actually take the post requests and interpret the input document, go out and fetch the data, assemble it, and send it all back. Clients are the ones that are requesting this. There's a couple of libraries that exist so that you can formulate your queries and mutations very easily. Servers are the guys that want to rip their hair out in this world. There's a lot of issues with security and optimization and scalability. That's a very big issue that I can see here. Fragments allow you to basically shorthand partials of types, so of a user type. If you're constantly referring to these sets of fields because they are a sub-entity of the user, in this case an address, you can use a fragment, which is basically a shorthand of these fields, and here is it in action. So we're just basically saying, give me only these 4 fields that correspond to this fragment as part of the all users query. You can also do things like parameterizing your fields. So like giving things like, give me the 30 most recent or the last 5, things like that. Those get injected into your resolver, and your resolver can use those and interpret that. Introspection is a great way for clients to see what models you support, what APIs you support, and different types and things like that. Bunch of different security things that I would say these aren't really security concerns, but these are more scalability concerns, scalability and security concerns, because like it's the same set of problems that they're trying to solve here, which is too much stress on your cluster. But there's problems with all of these approaches, which are what are suggested by them. So just keep that in mind if you're getting your hands dirty with this. So I've been going for almost 2.5 hours now, guys. I think I am done. Hope you guys liked this video. I'm probably going to do another one on the Java or Python example here for doing this on the back end, just to see how it works. I may do like a whole full stack thing to get started. But anyways, guys, thank you so much for watching, and thanks for sticking it out to the end if you made it this far. And yeah, I'll see you guys next time. Take care, guys. Have a good night.